Hello everyone. Good evening everyone, good evening. Okay, so I hope all of you are doing well, right? Am I audible to everyone? Yeah? Am I audible to everyone? Just give us a thumbs up. Am I audible to everyone? Give a quick thumbs up. Good evening everyone. Good evening everyone. Yeah? Okay. Okay, so in the last class, we started with the concept of isotopes, right? All of you understood isotope, right? Okay, so now we are starting with the base. We'll go through the isotope once again. Good evening, everyone. We'll go through the isotope once again, and then we'll come to the other atomic properties which we have to study, right? Okay. So in the isotopes, what we saw is okay. So in isotopes, the definition was that element, same element ka atom, right, having what? Same atomic number. We saw in the last class, same atomic number but different mass number, right? I hope all of you remember that. Same atomic number but different mass number. We took one example of hydrogen, which is known as protium, deuterium and tritium, right? Yes, protium, deuterium, tritium we have seen in the last class. And what we learnt is in isotope what is differing actually. What differs in isotope? Difference in isotope, we have observed that number of neutrons, right? Number of neutrons actually differ in isotope. Let me quickly go through it once again. Just let me quickly go through it once again. We'll see. So in the last class, what we saw is, what is atomic number? So atomic number is nothing but number of proton, which is denoted by symbol Z, right? So atomic number is equal to number of proton, which is denoted by symbol Z. And what was mass number? Mass number symbol A, mass number symbol A is equal to number of proton plus number of neutron, right? Number of proton plus number of neutron is equal to mass number, isn't it? We have seen in the last class. So it is also known as number of nucleons. Why number of nucleons? We saw in the last class. Why it is known as number of nucleons? Reason being, there is a nucleus and there are orbits, right? So electron revolve in the orbits. In the nucleus, what do we have? In the nucleus, we have proton, and in the nucleus, what do we have? Neutron. So mass, as we have seen in the last class, that mass of neutron is more than mass of proton, which is approximately equal, right? And it is very, very greater than mass of electron. So while considering the mass of atom, we consider only proton and neutron. We don't consider electron, because we have seen in the last class that mass of electron is very, very less in comparison to the mass of proton and mass of neutron. So wherever we write mass number, it is only about neutron and proton, neutron and proton, it is not about electron, isn't it? Mass number is only about proton and neutron, it is not about electron. I hope it is clear to everyone, right? Okay, just give me a thumbs up. Is it clear to everyone? Mass number has nothing to do with the number of electron. It is only about number of proton and neutron. Am I clear to everyone? Yes. So now we are starting with, so this is our observation. Now we are starting with the isobars. So in isobars, the definition is, what is the definition of isobar? In case of isobar, okay, so what is the definition of isobar? In case of isobar, atoms of same element having different atomic number, different atomic number, but same mass number. So mass number is same and atomic number is different. So that is the definition of isobars. I have one example. Here we have one example which is calcium 40 and 20, right? Now let me write each and everything about calcium 40 and 20. Now 20 is the atomic number. So let me write number of proton for you. So what is Z? Atomic number, which is also number of proton, which is equal to how much? Which is equal to 20, isn't it? Very good. What is the number of neutron? So mass number is equal to 40. Mass number is equal to 40. So what is the number of neutron then? Number of neutron is equal to, what is number of neutron? Mass number minus atomic number. So what is the number of neutron then? 20, right? So this is for calcium. For calcium, number of proton comes out to be 20. Mass number is 40, therefore neutron is 20. The definition says that having different atomic number but same mass number. So you see, number of proton 20, mass number 40. Other example I am taking is argon. So let us talk about argon. So this is 18 and 40. Now again, let us write the same thing. So according to the definition, different atomic number 18 and mass number 40. Yes, you see the mass numbers are same but the atomic numbers are different. You see, mass numbers are same but atomic numbers are different. So what is actually differing in this? So you see, number of protons are different, isn't it? So if I write number of proton is how much? Number of proton for this is equal to 18. Mass number is equal to how much? 40. So what is number of neutron then? Atomic mass number minus atomic number, which comes out to be how much? 22. Right? So in the last class, I asked you one question. What is that question? That for isotopes, which property is same and which property is different? Yes? In last class, I asked you one question for isotope, which property is same and which property is different? Same chemical properties due to same number of proton and electron, but different physical property due to different. Very, very good. Jitendra Kumar, very, very good. So, chemical property depends on number of electrons and proton. It has nothing to do with the neutrons. Why chemical property depends on number of electron? You see, this is the nucleus, right? And these are the electrons. So most of the time when chemical reactions are happening, I'll take one example. Let us say we are having sodium and we are having chlorine. Now, a chemical reaction has to take place between sodium and chlorine. What will happen? Sodium is a solid, chlorine is a gas. When they react with each other, what will happen? Sodium ka neutron is not going to participate. Sodium ka proton is also in that case not going to participate. What is actually going to participate in the chemical reaction is sodium loses one electron. Yes, sodium will lose one electron and sodium will become what? Na plus, right? All of you have studied ionic compounds. And chlorine will gain one electron and become what? Cl minus. And that is how what has been formed? NaCl. That means most of the time chemical properties depends on what? Chemical property depends on what? Chemical property depends on number of electron most of the time. So chemical reaction will happen with the electron. We'll come to that. We'll come after some time. We'll come to this knowledge. So isobars clear to everyone? Isobars clear to everyone? Just give me a thumbs up. Isobars clear to everyone? Different atomic number, same mass number. Different atomic number, same mass number. Is it clear to everyone? Okay. Okay. So let me come to the next topic then. So what is isotope now? Okay. What is isotope? What is right? Isobars, isotopes, isotones. So what are isotones now? Atoms of different element having same number of neutron. Having same number of neutron. Let us take the examples. So I'm writing calcium. Iso means same. Iso means same. Tones means what? Right now tones here means neutrons. So same number of neutrons of different elements known as isotones. Let me take the example. So we are having calcium 20 and 40, isn't it? So let me write all the values. Write all the values. what is atomic number Z is equal to? Tell me, what is atomic number Z? 20, which is also number of proton, because atomic number is equal to number of proton, right? Now, what is mass number? Tell me what is mass number. So mass number is equal to 40. And what is number of neutron? Number of neutron is mass number minus atomic number, isn't it? Mass number minus atomic number. So what is it? 40 minus 20 is equal to 20. So this is the number of neutron for calcium. Now let us come to the potassium now. So in the case of potassium, we are having 19 and 39. Let us write all the information. Let us write the information. What is the atomic number or number of proton? Atomic number is nothing but number of proton, which is equal to how much? 19. What is the mass number given? Tell me the mass number. Mass number is equal to 39. So what will be number of neutron then? What is the number of neutron? Number of neutron is equal to mass number minus atomic number, which is equal to how much? 20. So you see 20 over here and 20 over here. Number of neutrons are same, 20 and 20. Therefore, they are known as isoneutronic species. So they are known as isotones, or also sometimes they are known as isoneutronic species. What are they called? Isoneutronic species. They are also known as isoneutronic, or also known as isotones. Is it clear to everyone? Isotone is clear to everyone? Give a thumbs up please. Isotone is clear to everyone? Yes? Isotone clear to everyone? Yes. Number of neutrons should be same. Number of neutrons should be same. Okay. So I hope all of you understood. Number of neutron. Okay, great. Now, coming to the next one. Isodiaphers. Now, this is very, very important. You know, most of the time, people will miss all these things. And isodiaphers has been asked in the mains paper. What is isodiaphers? Now, let us come to this. Isodiaphers says that atoms of different element having same n minus p number. Very, very interesting. Having n minus p number. In the case of isotone, what we saw? In the case of isotone, what value should be same? A minus Z. In case of isotones, A minus Z value should be same. A minus Z value should be same in case of isotones. Now what should be same in case of isodiaphers? In case of isodiaphers, n minus p number should be same. Very, very interesting. Now what is n minus p? What is n minus p? We know that what is n value, just now I have derived. From the isotone, I can write, because number of neutron is equal to mass number minus atomic number. Because number of neutron is equal to mass number minus atomic number. Therefore, what will be n minus p? Bolo beta ji. What will be n minus p? A minus Z. And what is p? Number of proton. So what is proton? Proton is nothing but atomic number. So this value comes out to be what? A minus 2Z. Is this clear to everyone? Give us a thumbs up quickly. Is this clear to everyone? A minus 2Z. N minus p is nothing but A minus 2Z. Is it clear to everyone? Is it clear to everyone? N minus p is equal to A minus 2Z. Very good. Okay. So I can write either same number of proton minus number of neutron minus proton. Okay. Very easy. Idhar dekho, everyone. Number of neutron is mass number minus atomic number. Right? So I can write here A minus Z. And what is P? P is proton, which is nothing but atomic number, right? So P is nothing but atomic number. So this comes out to be A minus 2Z. Isn't it? So this is N minus P is nothing but A minus 2Z. So both could be asked in the papers. Okay, what is the meaning of isodiaphers? Either their N minus P number should be same, or their A minus 2Z value should be same. Okay, now let us come to the example. Let us talk about example now. So in this case, I can write over here so boron. Boron, atomic number 5, mass number 11. So let me write each and everything. So what is atomic number? Number of proton, which is equal to how much? 5. Very good. What is mass number? Mass number is equal to 11. Mass number is equal to 11. So what is n minus p value? N minus p value is equal to number of neutron. We don't know neutron, right? So let me calculate the neutron first. So neutron I can calculate here. So number of neutron is equal to A minus Z, right? A minus Z is equal to number of neutron. So what is that? A minus Z? 11 minus 5, which comes out to be 6, isn't it? So what is n minus p value then? So n value is 6, p value is 5, which is equal to 1. Very good. So this value is 1. All of you have got that value, isn't it? Now, what is carbon? Carbon is 613. So I can directly write now, right? I can directly write A minus 2Z. What is A minus 2Z? Mass number is 13 minus 2 into atomic number Z. What is atomic number? 6. So what is that value? 1. So either you write n minus p or you write A minus Z, both are same. And the value comes out to be same, isn't it? So this is called as isodiaphers. Atoms of different element having same n minus p number or same A minus 2Z number. This is known as isodiaphers. Isodiapher clear to everyone? What is isodiaphers? Clear to everyone? Just give me a thumbs up quickly. Is it clear? I'll go to the next topic now. Is it clear to everyone? Isodiaphers? Okay, great. Now coming to the next topic. Isosteres. So what are isosteres? Same number of atoms and electrons. Now this is very, very interesting. Any given compound or let us say molecule which are having same number of atoms and same number of electrons are going to be known as isosteres. Okay, let us come to the isosteres now. Now we are having two examples, carbon dioxide and N2O. Now this is very interesting. So first we have to count number of electrons. I have told you in case of neutral state. Okay, I think next topic is isoelectronic, right? So before that, let us learn how to count. Let us learn how to count number of electron, right? Chalo. We'll take few examples. Let us count number of electrons first. So if I have C, carbon atom. So in case of carbon atom, number of proton and number of electron both are same because it is a neutral atom. What I want to say is there is a nucleus, there is first orbit, there is second orbit. All of you have studied this. How many electrons in the first orbit? 2. How many electrons in the second orbit? 4. Right? So total number of electron is equal to 6. And inside of the nucleus, how many protons are there? 6 protons. And we know that one proton carries plus 1 charge and one electron carries minus 1 charge. So 6 proton will carry what? Plus 6 charge, and 6 electrons will carry minus 6 charge. And that is how, because of same charges, atom is electrically neutral. Because of same charges, atom is electrically neutral. So carbon is a neutral atom. Reason being, it is having same number of electron and same number of proton. So if I write atomic number 6, which is equal to number of proton, if it is electrically neutral, it should also contain 6 electron, isn't it? So proton will be equal to electron if it is a neutral atom. Remember, if it is a neutral atom. Now, let us come to the ions. If I talk about ions, what does it mean? So ions are of two types. One is called as cation and one is called as anion. Ions are of two types. One is called as cation and one is called as anion. Right? Now, cation is something which loses electron, right? Let us say if you remove one electron. Okay, let me take one example actually, then we will understand. Okay. Let us say that I am having which atom? Let us say that I am having, let us say magnesium, right? I am having magnesium atom. All of us know that magnesium is electrically neutral. In that case, it is having atomic number 12. Atomic number 12 means what? number of proton is equal to number of electron, which is equal to 12. Then only it is electrically neutral, isn't it? Now, let us say if I remove one electron, you can look at the structure also. This is the nucleus, first orbit, second orbit. So 1, 2, then 1, 2, 3, 4, 5, 6, 7 and 8, 8 to 10. Now, this is the third orbit containing, let us say, 2 electrons. Now, this is very easy to everyone. This electron, I'll take the another marker, some other color. Okay, which color I should choose? Should be visible to you guys. White color. Okay, so this electron which is closest to the nucleus, will feel maximum attraction. Because it is close to the nucleus, will have maximum attraction, isn't it? Now, this electron will have least attraction with the nucleus. Outermost electron will have least attraction with the nucleus because it is away, right? So, which electron I can remove easily? The outermost. So, the outermost electron I will remove, one electron at a time. If I remove one electron, magnesium, now magnesium contains how many proton? Proton is still how much? 12, because the atomic number is 12. See, I have not done anything with the proton. I am not touching nucleus, you see. I am not touching nucleus. I am not removing protons. When I am creating any charge, I am creating a charge +1 because I have removed electron. I have not removed proton. I hope it is clear to everyone. Proton ka value will remain same. Proton ka value is 12, it is 12. But electron from 12, they have become 11. So proton 12, electron 11. Now, is it electrically neutral? It is not electrically neutral. Yes or no? Why it is not neutral? Reason being, electron are 11 and protons are 12. So 11 proton will neutralize 11 electron, but one electron is in excess. Sorry, one proton is in excess. So 11 proton, 11 electron, one proton is in excess. And proton carries +1 charge, therefore magnesium will have plus charge. If I remove one electron, isn't it? If I remove 2 electrons, magnesium will become magnesium 2+. Have I done anything with the proton? No, I have not done anything with the proton. I cannot touch nucleus. If you touch the nucleus, nuclear energy, you can vanish the whole city if you touch the nucleus. You can't touch the nucleus. When chemical reaction happens, we are only talking about electron. Either you add electron or you remove electron. That is the chemical reaction. That is the chemical reaction. Only about electron, not about proton. You are not going to touch the nucleus, otherwise you will you'll have a bomb or something. Nuclear energy, it's very, very high energy. You will study all these things. So, we are having 12 proton but 10 electron. So, because 10 electron neutralizes 10 proton, so you have 2 extra proton, therefore +2 charge. So, whenever we have plus charge or minus charge, we are only adding electron or removing electron. If you remove electron, you contain plus charge. Now, if you add electron, let me say that I am adding electron. Now, let us say I have a chlorine atom. Chlorine contains 17 proton and 17 electron in its neutral state. Chlorine is electrically neutral initially, atom. It will contain 17 electron and 17 proton. But if I add one electron, this will become Cl minus. Again you see, I have not done anything for the proton. Proton ka number is same. What I have done is, I have added electron. So how many electron now? 18 electron. So again, 17 proton and 17 electron cancel each other. One extra electron becomes negative charge. Is it clear to everyone? Is this concept clear of ion? Cation and anion, just give me a thumbs up quickly. Is it clear everyone? Cation and anion concept. We are not doing anything with the proton. We are either removing electron or we are adding electron. We are not doing anything with the proton. Is it clear to everyone? Okay. Okay, great. Great. Now, so coming to this. So what are isosteres? What are isosteres? So isosteres means same number of atoms and electrons. Now look at this, CO2. In CO2, number of atom number of atom is equal to 3. In case of N2O, number of atom is equal to 3. Number of atoms are same. Now, what about number of electrons? Let us count the electron. Carbon contains, what is the atomic number of carbon? 6, neutral. So atomic number 6, number of electron will be 6. So 6 electrons in the carbon atomic number, and atomic number of oxygen is 8, so 8 into 2. So which is equal to 22, right? Now, what is the number of electron in case of N2O? Nitrogen ka atomic number 7. So 7 will be proton and 7 will be electron because they are electrically neutral, right? So this will be 7 into 2 plus oxygen is how much? 8. So this is also equal to what? 22. So these are called as isosteres. Is it clear to everyone? Isosteres, is it clear to everyone? Give me a thumbs up quickly. Isosteres, clear to everyone? Very good, 22, 22. Both number of electrons and number of atoms, both are same. They are known as isosteres. Number of atom and number of electron, if both are same, they are known as isosteres. Great. Okay, great. Very good. Now what we are going to learn is what is isoelectronic. Could I explain over here, isoelectronic? Okay, I am writing over here, isoelectronic. What is isoelectronic? The name itself suggests something, isn't it? What name suggests? Iso means same, electronic means number of electron. So if number of electrons are same, those species are known as isoelectronic. Now, let us come to this. What are the examples? What are the examples? Okay. Now, let us say sodium. Sodium contains 11 electron as well as 11 proton, isn't it? Can I write example over here? Do I have space over here? Where can I write? Okay, I'll write isoelectronic here only. Okay, here only I'm writing isoelectronic because I've written something on the next page. So isoelectronic, I'm taking examples. Let us say we are having neon. I think all of you know number of electrons, right? Neon. So what is the atomic number of neon? 10, right? Therefore, number of electron will be also, number of electron I'm writing here, okay. So number of electron will be also 10 because atomic number is equal to number of proton is equal to number of electron for neutral atom, not for charged one, for the neutral one, isn't it? Neon. Next atom I am taking, let us say fluorine. Now all of us know that fluorine ka atomic number is 9. If you don't know, please remember the atomic number. Fluorine ka atomic number 9. If I add one electron, I'm adding one electron, so this will become F minus. Because it has become F minus, it will have again how many electrons? 10 electrons. So I'm directly writing over here, I'm directly writing fluoride ion will contain 10 electrons, isn't it? So fluoride ion will contain 10 electrons. Now oxygen. Oxygen is having atomic number 8 is equal to number of proton is equal to number of electron. If I accept 2 electrons for the oxygen, 2 electrons, what will be the charge on oxygen? 2 electrons, so 2 minus. Because 2 minus, already it was having 8 electrons, so electron become what? 10. Isn't it? Now, let us say that I am having sodium. Because I am having sodium ka neutral state atomic number 11. Now don't add electron, remove one electron. If you remove one electron from sodium, it will become Na plus. Initially sodium contains 11. If you remove one, it becomes Na plus and become what? 10, isn't it? So sodium plus will become 10 electrons. Similarly, having magnesium. Magnesium ka atomic number 12, which is equal to number of proton equal to number of electron, isn't it? In neutral state. If I remove 2 electrons, so 2 proton is in excess. Isn't it? Samajh nahi aaya? Let us say 12. Magnesium means what? 12 proton and 12 electron. So if I remove 2, then 12 proton and 10 electron. So 10 proton and 10 electron cancel each other. What is excess? 2 proton. And what is the charge on 1 proton? Plus 1. So total charge will be plus 2. So magnesium 2 plus contains again how many electrons? 10. So these are known as isoelectronic. What is isoelectronic? Containing same number of electron. Is it clear to everyone? Just give a thumbs up quickly. Is it clear to everyone? Isoelectronic species clear to everyone? Containing same number of electron. Yes, carbon also 4 minus. Yes, carbon 4 minus will also contain 10. Yes, absolutely correct. Carbon contains 4 minus. Yes. Carbon 4 minus will also have 10 electrons. Yes, definitely that will be also known as isoelectronic. Any anion or atom having same electron will be known as isoelectronic. No doubt about that. Okay. Carbon 4 plus nahi beta. Carbon 4 plus to initial atomic number is 6. It will become 2. No, not that. Aluminium 3 plus, not 3 minus. Aluminium 3 plus, definitely. Aluminium 3 plus will also contain 10 electrons. So this is also isoelectronic. Carbon 4 minus also contain 10 electrons. This is also isoelectronic. 4 minus, definitely I have written. See, 4 minus. Carbon 4 minus also isoelectronic. Charge number, that is what I am saying, no beta ji. No, carbon can only form covalent bond. Who said to you? Carbon can form ionic compounds as well. Who said to you? Na2 plus nahi beta, Na plus 1. Na plus 1. Carbon dominantly forms covalent. Dominantly, not always. I'll show you inorganic compounds. Arey, you don't know beta ji, that is high school knowledge. Carbon cannot form ions, that will form the ions. I'll show you. Very rare, but yes, it is possible. Okay, now. Arey, that is high school knowledge beta. Carbon nucleus cannot hold 10 electron. High school knowledge. Okay, now coming to the next topic. Now what we are going to learn is very, very important. We are going to learn the nomenclature of inorganic compounds. And let me tell you, it is very, very important, and nobody is going to teach in 11th class because the syllabus, time given for the syllabus is very less. So nobody is going to teach you this, what I am going to teach you here. So this is very, very important. You listen to the class, how to do the nomenclature. Otherwise, you will suffer throughout the preparation, I am telling you. So listen very, very carefully. Okay. Now, molecules. Everybody knows what is molecule. Aggregate of atoms is known as what? Molecules. I think there is nothing to be told about it. Aggregate of atoms is known as molecules. I think it is clear to everyone. Yes? Okay. What is ion? Ion. Either electron could be lost or electron could be gained. See, I have already written. So we have two types. One is called as cation. I told you, some of you are asking charge numbers. So I'm telling you, cation and anion. Right? So let us say we are having sodium. Sodium atomic number 11. 11 electron as well as 11 proton. I told you, you don't touch proton. Proton is inside the nucleus. If you touch the nucleus, you'll have a bomb, you know. You can't touch the nucleus. So you are removing electron. If you remove electron, 1 electron to become plus 1. If I add 1 electron, let us say I'm adding 1 electron. If I remove 1 electron, plus. If I add 1 electron, minus. This is how we find the charge number. If you add 1 electron, 1 minus. 2 electron, 2 minus. 3 electron, 3 minus. Don't think about removing or adding proton. We cannot add or delete proton. We are only looking in terms of electron. Electron can be removed. Electron can be added, and that is how chemical reaction takes place. We'll come to that. Don't think about the proton. Okay. So now, cation and anion we have seen. Now there are two types of ions. Two types of ions. One is called as monatomic, one is called as polyatomic. For example, let us say we are having aluminium 3 plus. So this is having single atom, so monatomic. Let us say we are having F minus. Single atom monatomic ion. Let us say I am having O2 minus, oxide ion. Single atom monatomic ion. What are polyatomic? Those ions which has more than one atom. Right? Those ions which contain more than one atom. More than one atom is known as polyatomic. Example, sir, example. Let us come to the example. So in polyatomic, you can have cation as well as anion. We can have cation as well as anion. So cation, polyatomic cations are very, very less. Mostly we have polyatomic anions. Cations are very few. We'll take, let us say that one cation NH4 plus. So this is called as ammonium ion. We'll come to the nomenclature later. So NH4 plus, having a charge, add more than one atom, isn't it? Anion, hydroxide ion, I think all of you know OH minus. Hydroxide ion, OH minus. Cyanide ion, Cn minus, isn't it? Are you getting my point? So these kind of anions are known as polyatomic. And single atom containing charges, they are known as monatomic. Again, monatomic can be also cation as well as anion. Polyatomic also can be cation and anion. The only thing is, single atom in polyatomic more than one atom. Cation as well as anion. Now, we are starting with the nomenclature. Now, once we come to the nomenclature, generally how do we write the names? How do we write the names? First we write the cation, prefix, and then we will write the anion, suffix, isn't it? First we write that O3. O3 is molecule, no ozone, it is not having charges. Venkat Prabha, you will get to know beta ji. +4 is not possible, -4 has been possible. There are few compounds which are formed. You will come to know in 12th class, 11th and 12th class. Okay, so now coming to the next thing, formula of ionic compound. So before we go to the nomenclature of ionic compounds, it is very important how to write the formula. So first we will write the formula, and then with the formula we will write the names. So this is, I have given this definition for you only, you read this, right? Thiosulfate will come to everything, beta ji. Thio, I'll come to everything, don't worry, just go with me, just go with my flow. I'll teach all the nomenclature which is very, very necessary, don't worry about it. Now, so what are the formula of ionic compounds? For ionic compounds to be electrically neutral, the sum of the charges on the cation and anion in each formula unit mass be 0. Now what is formula unit? This is very, very important. What is formula unit? So when we are forming ionic compounds, generally ionic compounds NaCl. So it is not one atom or one ion. So therefore we say it is a formula unit. Okay. So the charge, overall ionic compound should be neutral. The most important point is ionic compound should be neutral. Ionic compound should be neutral. How to neutralize this? Now, if you are having same number of cation and same number of anion, it means that they should contain same charge. What I mean is, let us say we are having sodium plus and Cl minus. Now you see, same charges on sodium and same charges on chlorine. So you don't have to multiply any number because they are already electrically neutral, isn't it? So you see, this is NaCl. Yes or no? Now, let us say that I want to have something else. Let us say I want to have zinc oxide. Very good. Now, let us say I want to form zinc oxide. Zinc oxide. Now, I think all of you know that oxide means O charge minus 2. What are the names? Will come to that. Oxide and everything will come to that. For now, before we'll come to the nomenclature. Don't worry, I'll tell you how to write oxide and this and that will come to that. For now, I'm saying to you, zinc means Zn2 plus. Just right now, just believe this. I'll come to the nomenclature. Zinc means Zn2 plus, oxide means O2 minus. Now, do I need any number? Zinc should be 2, oxygen should be 4, anything like that? No. Why we don't do that? Because the charges are same. When the charges are same, they are already electrically neutral. When the charges are same, they are already electrically neutral. So you simply write zinc oxide. But now coming to the interesting part. Let us say that we are having magnesium nitride. Let us say you have been given to write magnesium nitride ka chemical formula. Now magnesium nitride, how to write? Now I'm telling you for now, nitride, I'll tell you, see I have all the tables over here. You can follow that later on. See, everything I've written. What is nitride? Actually I have one more table. Let me see. Yes, so I have all the ions for you written over here. Don't worry about that. Yes, this is the table. So every ion is written over here. You know, every ion is written over here. Don't worry about that. So I have kept everything over here. No need to worry about it. Okay. Simply go with the concept for now. Okay. So I was saying that how to write magnesium nitride. So nitride, abhi I'll tell you the periodic table, then I'll tell you why 3 minus charge. So for now, nitrogen contains 3 minus charge. Why 3 minus charge? Some of you might be knowing. What is that? So 2 electron and 5 electron. 2, 5 is the electronic configuration. Tomorrow is our topic of configuration. We'll go in more detail. So 2 and 5, and we know there should be completion of octet. To complete the octet, this should accept 3 electron. Therefore, nitrogen will carry 3 minus. And magnesium, if you know the electronic configuration, magnesium, what is it? 2, 8, 10 and 2, right? Now, octet rule, it should contain 8 electrons in the outermost orbit. Therefore, it will remove 2 electrons, and once it removes 2 electrons, it will become magnesium 2 plus, isn't it? And this will become N3 minus. Now it is very interesting. You see, now the charges are not same. When the charge, I'll write over here. When charges are different, apply crisscross method. I think all of you have studied this in high school. So this is very basic. Abhi I'll come to oxo acids, acid and base, acidic radical, basic radical. That is more important. For now, most of you might be knowing it, but some of you might not be knowing. That's why I'm discussing it. My focus is acid radical, basic radical, oxo acids ka nomenclature, which you don't know, which is very useful in coming classes. Okay, so charge are different. So apply crisscross. If charges are same, no need to do anything. Simply coming together. Nothing else is needed. Okay, so apply crisscross. Apply crisscross. What I mean is crisscross. So this number should come over here and this number should come over here. What I mean is magnesium, what is the number? 3. So it should become like this. Subscript, it should become subscript. Mg3 and it will become N2. So what is the charge now? 3 magnesium and 2 plus charge. 3 magnesium, 2 plus charge, how much? Plus 6, isn't it? 2 nitrogen minus 3 charge, minus 6. Now it is electrically neutral. So what is magnesium nitride then? So magnesium nitride is Mg3N2. So what we did is, if we are having different charge, apply crisscross. That means charge should become subscript of the numbers. Magnesium nitrate nahi bola beta. Magnesium nitrate nahi. Magnesium nitride. I am not saying nitrate. NO3 minus, that is different. I am talking about nitride. Nitride, D. Nitrogen containing 3 minus. That is nitride. Okay. So now we are coming to the naming of compounds. So I'll erase this example. I'll write it over here only. I'll write in this only. What is this? Okay. Yes. Formula of ionic compounds. Remember, if charge is different, what to apply? Crisscross. Apply crisscross. Okay. So this is the naming of the compound. This is a very beautiful table over here. You can follow this. I'm going to explain this with the help of so many examples. Now please remember, this topic which you are going to cover now, most important. If you don't understand here, you will suffer in your 11th and 12th. Already I'm saying to you. Okay. Now, compounds are of generally 2 types, ionic compounds and molecular compounds. Molecular compounds means what? There should be formation of covalent bond. Covalent bond, all of you know sharing of electron, isn't it? Sharing of electron, covalent bond. So one category of the nomenclature is molecular compounds ka nomenclature and one is ionic compound. For now, we are not going to discuss molecular. We are focusing on ionic compounds nomenclature. Okay. Now, ionic compounds. Cation generally, what will be generally cation? Idhar likha hai, you can read it after the class. Cation will be generally metal pe charge, either metal charge or one ammonium ion. So whenever you find cation, it should be either M pe, metal pe plus charge, or it should be generally ammonium ion. Please remember, cation either metal ke plus charge or ammonium ion. In anion, as I have told you, anion could be monoatomic or polyatomic. oxide, fluoride, chloride, bromide, cyanide, iodide. Okay? Okay, I'll write it better. No clarity, I'll write it again, don't worry. No clarity, don't worry. This PDF will be uploaded to you, so you can read it over there. Right now, it might not be visible, but I'm explaining to you. Yeah, I know table is blur, but once, yeah, it will go to your, it will be uploaded PDF, so you can look into that. Right now, I'm explaining, don't worry. Okay, so ionic and molecular. So this is ionic. This table over here, it is written as ionic. So for ionic, how to do the nomenclature? So first we'll have two kinds of ions, cationic or anionic. Cation, what will be cation? So cation will be generally metal, metal pe plus charge or NH4 plus. So these are the only cations we are going to find. And what are the anions? In case of anions, we are having, just now I discussed you, monoatomic, polyatomic like that. For example, Cn minus, I minus, F minus, this and that. Now, let me come to this one. Now, cation ka further classification. This is what is written, I think there is doubt. Now, this is cation has only one charge. Left side is cation has only one charge. Right side is cation has more than one charge. Cation has only one charge means what? Alkali metal, alkaline earth metal and few elements. This will get it. I think it is not visible to you guys. So I'll go to the next slide and I'll explain you how the nomenclature is being done. Don't worry. Okay. So first we write cation, metal. Either you have metal ions or we have ammonium ion. NH4 plus is known as ammonium. Please remember. So first we write cation and then we will write anion. Cation followed by anion. Now how to do the nomenclature of cation and anion? That is very, very important. I will take with examples. I'll start with few examples. Let us say that I want to do the nomenclature of NaCl. Please listen very, very carefully. How to do the nomenclature of NaCl? So you start with the cation. What is cation? Sodium. Cation is sodium. Now remember, whenever we are writing anion should end with "ide". Anion should end with "ide". Please remember, anion should end with "ide". So what it will become? Hydrochloride, sodium chloride. So Cl minus, whenever you have a negative ion, it should end with "ide". I'll take few more examples. Let us say that I'm having, what I should take? Magnesium, MgCl2. So what should be the name? First cation, magnesium. First cation, magnesium. Then what we write is chloride, magnesium chloride. Magnesium chloride. So, okay. So there are few metals. Now this is very, very important. This is the table of metal ions. In this one, I'll explain again. Don't worry. Don't worry. I'll explain again. So you see, you look at this one, Cu. Now these are the metal ions which exist in more than one charge. Why it exists in more than one charge, we are not going to discuss now. But remember, there are few metal ions which exist in more than one charge. For example, Cu plus 1 and Cu2 plus. Oh my God, now how to do the nomenclature? I'll take example. Let us say that I'm writing CuCl2 and I'm writing CuCl. Now how to do the nomenclature? This will be copper chloride and this will be also copper chloride. What is the difference into that? This is also copper chloride, this is also copper chloride. What is difference into it? How to differentiate the nomenclature? I'll come to that. Why 8? I'll come to that, beta ji. Don't worry. I'll come to that. What is the name of this? So remember, this is called a stock nomenclature. This is called as stock nomenclature. Not a Stark. I'm not talking about Tony Stark. I'm saying stock nomenclature. Stock nomenclature. So what is stock nomenclature? When a metal ion has more than one charge, more than one type of charge, then what we write? Then we write metal name, and then in bracket we write Roman numerals. For example, 1, 2, 3 like this. And then we write ion. Then we write anion. That is how we write. So whenever there is a metal ion which is having more than one charge, cuprous, cupric, I'm coming to that, Betaji, don't worry. First, understand what is stock nomenclature. According to stock nomenclature, when a metal ion has more than one type of charge, you write the charge in bracket, parenthesis. For example, what will be CuCl? This will be copper. What is the charge? Cl is -1. For the neutrality, Cu will be +1. So what is this? Copper in bracket you write 1 and then you write chloride. Copper 1 chloride. This is called a stock nomenclature. Stock nomenclature is only applied for those those metal ions which is having more than one charge, more than one kind of charge. Okay. Now, what about CuCl2? How would you write CuCl2? I will write over here. CuCl2. Now, you write copper, and then what we write is copper 2, right? Because there is 2 minus, it should be 2 plus. 2 chlorine, therefore 2 Cl minus, isn't it? So copper 2 chloride. This is called a stock nomenclature. Stock nomenclature clear to everyone? When it will be applied, give me a thumbs up. Stock nomenclature clear to everyone? Just give me a thumbs up. Stock nomenclature clear to everyone? No, CuCl2 only. Just give me a thumbs up. Stock nomenclature clear to everyone? Yes, copper 2 chloride. Very good. So this table is given to you. This table is given to you. It will be uploaded. You read it once again. Okay. You read it once. So let us say we are having. I'll take one more example. Okay. So we are having. See, SN2 plus and SN4 plus. I'll take one more example so that you can understand. SnCl2 and SnCl4. That means here, what is the charge? +2, and here what is the charge? +4. So what, according to stock nomenclature, how we are going to write the name? We are going to write the name tin, Sn tin. What is the oxidation number? What is the charge? 2. So write in bracket 2, and then we write chloride. Tin 2 chloride. That means on the tin there is plus charge, +2 charge. Therefore, how many chlorides should come? 2 chlorides should come. So you can write the formula. Now, for this what we are going to write is tin in bracket charge in Roman numerals 4, and then you write the chloride. So this is called a stock nomenclature. Stock nomenclature is applied for those elements, those metal ions which carry more than one kind of charge. That is called as stock nomenclature. Now, very, very important. Now what I'm going to say is, what is the meaning of us and what is the meaning of E, and these are the suffix and when they are used. So I'm going to use them now. So please remember, whenever a metal ion has more than one charge, let us say we are having Sn2 plus and Sn4 plus. Or let us say, I'll take few more examples. We were having, let us say, CuCl2 and Cu. So that means Cu plus 1 and Cu plus 2. So what is meaning of us and ik? Listen carefully. So Cu plus 1 and Cu plus 2. Stock nomenclature is different, this is different. So to avoid Roman numerals, what we say is, time is up, okay. Just 2 more minutes, guys. So Cu plus 1, lower charge, I'll write lower charge, suffix is us. Lower charge suffix is us. That means for Cu plus 1, you are going to write cuprous. And if charge is more, for the same metal ion, please remember, for same metal ion, more charge means the suffix will be ik. This is not stock nomenclature. So what we are going to write is, what will write? Cupric. Similarly, you can write for lead also. Somebody is saying lead. Pb2 plus and Pb4 plus. Okay. So what is I8 and what is 8? Why they will come? So we'll come to the acids and base. and then nomenclature, oxo acids and oxo. So tomorrow's class will be very, very important. So tomorrow we'll finish the nomenclature. Please be in the class. Please be in the class. That is very, very important class. Tomorrow's class is very, very important. Just now I've started with the idea of nomenclature. There is so much to study now. So we'll cover approximately 1 month. So we'll cover this one, and we'll start with the electronic configuration tomorrow. Okay. Thank you guys. Thank you so much. Okay. Thank you.